24-bit wildcard mask, 0.0.0.255, and it's in what area? 192. It also is in the 2 network, right? It's participating in the 2 network. Now you'll see when I bring it up the 2 network, OSPF is going to bark out a neighbor advertisement. And what OSPF does is, when it barks out a neighbor advertisement, if a corresponding OSPF router is on the same network and hears it, it's going to respond. It has to be in the same area. If it's in the same area and participating in the same network, they're going to form what we call an adjacency. Okay? Once that adjacency is formed, they are going to trade routing tables. And when they trade routing tables, R1 in this case is going to learn about the 192 network, and R2 in this case is going to learn about the 10 network. Okay? Case in point. If I do a do show IP route on R2, I don't see the 10 network. Everybody get that? Cool. Still in router configuration mode. I do net 2.2.2.0, 0.0.0.3, area 0. Watch what happens when I hit enter. See it on both of these. They form that adjacency. Now, if I do that show IP route on R2, I now see the 10 network. Yeah.
Sorry,
It's okay.
Pretty obvious. I'm pretty sure it's obvious, but for the areas, I don't know if they're giving to us here, but when we're trying to figure it out, is it just that we keep the first
No, that's arbitrary. Okay. Now, in the labs and in the exam, I would give that to you.
Okay.
If you're out in the wild, so to speak, hopefully somebody has it documented somewhere. If you're building what we call a greenfield environment, pick something out of the sky. Okay?
So they're giving to us for usually make it
Yes. I will give it to you, or if I don't give it to you, pull it out of the sky. Good question.
Yeah, I was just wondering.
No, it's a good question.
Because I got area 10, 192, but then
Sure.
area 0 was like.
That's
where
fine.
do you get that?
I just did that for simplicity's sake to not mess anybody up. Okay? All right. Moving on. Now that I have full internet connectivity, go back to the lecture here. We're going to go back to talking about ACLs. Now, for your labs, when you get into lab 2 and 3 and test number 1 and 2, that right there, or a derivative of it, whether it is setting up EIGRP or RIP or static routes, okay, IP addressing everything, getting that internet connectivity, internetwork connectivity, that is going to separate you, okay, the A students from the B students, the B students from the C students, the C students from the D students, and so forth. Because that is question number 1. If you don't get that, you lose automatically lose the letter grade. Period. You have to have full connectivity so that you can make everything work. Hence why I said it was important to take 347 before you take this class. Alright? Now, nothing that you can't overcome working with maybe a study group or your partners or doing a little bit of research out of class or recording. Right? Alright, are taking good copious notes. What are you up to, page 3 now?
Yes.
Awesome. God, I need a transcript. You know, I woe the day that I have. Step back here real quick. I went to my last PhD residency at Arizona State last month, and one of my fellow students that was in there, he is completely 100% deaf. And as part of what the university did is they had a court transcriber, what they call a court stenographer or whatever they're called. sitting there typing as the different presenters and lecturers and PhDs were coming up and giving us information on our comprehensive exams and our dissertation and everything else. And he was getting everything on a screen. He was watching everything on a screen. So, like, shorthand from hell, man. That's awesome. Thank you. Okay, access list. All right, when do we use an access list? Well, it's called for when we have to lock down applications or use advanced features or control resources of applications in depth. There are two types of access lists that we're going to use in this class. A standard access list and an extended access list. Okay? And a standard access list, and they're numbered, basically. Or they can be named. Use them as a named access list. Alright? I messed this up last time. Okay? The standard access list is going to be numbered 1 through 99. An extended access list is going to be numbered 100 through 199. Now, a standard access list is written access list, number, permitter deny, network number, wildcard mask, where the network number equals the source IP, and the source IP only. Standard access list only filter on source IP number. A little limiting, right? A little limiting. Okay? So if I were writing a standard access list, I could only inspect based on the source IP address. Okay? So I can either permit or deny where traffic is coming from, not where it's going to. An extended access list, right, will allow me to permit or deny based not just on IP, that IP source, but on layer 3 or layer 4 protocol. It'll allow me to permit or deny based on a specific IP, a specific host, or, like the standard access list, a network and wildcard mask. But it will not only allow me to do source, it will also allow me to do destination and by a destination port number or source port number. I can also do it by source port number, although that's, you don't want to get into that. Okay, it's not really necessary. But it'll do it by destination port number. Yes?
What were you saying about the numbers? We have 8.
When I get into it, it'll explain itself.
Okay.
Okay. All right. It's just a piece of the code command.
Okay.
All right. So what I'm going to do now, covered. All of this is done via IPv4. So we're going to concentrate on. We're not doing this. You can do this with IPv6, but we need to crawl before we run. So we're going to concentrate on IPv4. All right. In this class, we're going to use RFC 1918. All right. RFC 1918 is what? They explain that to me. Private IP addressing. Where would you never find these addresses? Never, ever find those addresses
On the internet?
on the internet. They're for private use only. They are not publicly routable. Okay? Now that's important because you're going to get questions in your labs and in your tests where you have to filter that using a standard access. Using a standard access. So you'll build an egress filter stating that if any packet is destined to the internet with that source address, it gets dropped. That is best practice for any edge router that's on the internet. Any edge router on the internet. Now your ISP is going to filter it anyway inbound, but It's just best practice to do that. Next. I hope I don't need to cover subnetting, inverse subnetting, or wildcard masking, private IP ranges, and IP registration. You guys should have that. If you don't, do a couple Google or Wiki searches on it. You should have that down by now. Should have that down by now. Okay? So, ACL configuration. There's a couple steps you need to know. You create the ACL, and then you apply the ACL to an interface. Alright? Creating the ACL, if you look at table 2.5 or 2.6 in your book, kind of explains it. You also, it gives a map of the traffic diagram. Alright? Example of this map diagram is when traffic goes into an interface. Alright, and an access list is there to be used. Or in this case, two access lists. It follows a certain flow. So when packets come into an interface, they enter the receive buffer. If there's an access control group on that interface, that acts as a pointer. Y'all remember what a pointer is from programming class? Y'all remember what a pointer is from programming? Good. Points to an ACL. That ACL is then a list of code that is basically an inspection standard, and it goes to the parameters of that inspection. Okay, line by line. Beginning to end. Forward to back. Front to back. Alright? And then after it goes through that inspection process, that packet is either allowed or denied. Now, as it goes through that access list line by line, once it hits an entry where it's permitted, it stops. Stops that process. It stops going through that access list. And it gets put to a route table check. So, once it's past that access list, is that destination address in my route table? If it is, great. It gets processed to the transmit buffer of the exit interface. If it's not in the route table, the packet gets dropped. Okay? Once it goes to the transmit interface, it goes to and sees if it has a exit access control group, which acts as a pointer to another access list, if that access list exists. Okay? If this access list doesn't exist and this access list doesn't exist, these steps are just skipped. Okay, but if one exists, it then looks up that exit, that egress access list, and it goes through the same process until it's matched. If it's matched, great. It gets put to the transmit buffer and gets shipped out that interface. If it doesn't get matched, it gets dropped. If it goes through all the way through the access list in either step, there's an implicit deny at the end of an access list. Meaning, if you didn't match anything in my access list, you are automatically dropped. Okay? So that's that entire process of how an access list operates. Okay? And how a packet traverses a router. So you have to understand the direction the ACL will be traveling and whether it's going to be inspected inbound or outbound. That's very important when we get to configuring the access group command on the interface. So remember this, because this is a very, very, very rookie mistake, and you'll lose 5 points for every access list that you have to configure. You could do a beautiful access list. You could get everything right. Your permit statements, your deny statements, your source and destination, your ports, everything else, right? And you're set up to get 10 points on that question. You don't apply it to the correct interface, okay, at all, you'll lose 5 points. You apply it to the interface, but you put it in the wrong direction. You apply it inbound when you should have applied it outbound, or vice versa, you'll lose 3 points. Okay, so pay attention to this when I go through applying the access list with the access group command, the IP access group command. Okay, and pay attention whether I apply it inbound or outbound. And that's based on where the access list is going to reside. Okay, we went over the processing piece. So now we're going to implement a couple of ACLs. First thing we're going to do is we're going to implement a basic plain Jane inbound standard ACL on R2's S10 interface. Okay? And we're going to deny IP. We're going to break this network. We're going to break the network. We're going to break OSPF. Okay? So, here's how we do that. On R2, I'm going to go ahead and write a standard access list. The command is access list, a number between 1 and 99. I'm just going to pick 10. It's arbitrary. I then have to say permit or deny. In this case, I'm going to deny the address from which I'm coming from. So I'm going to deny the 10.0.0.0 network. It asks for a wildcard mask, 0.0.0.255. Enter. Now I need to permit everything else. So I'm just going to put a access list 10 permit IP any. Oops. Standard act permit any. There. If I do a show running configuration, there's my access list. So, alright, it'll permit anything from the 10 network, it'll deny anything from the 10 network, it'll permit anything otherwise. I need to apply that to the S10 network. So if I go into the interface serial 10, I gotta use the IP access group, the number which corresponds to the access list, which is 10, and then is it inbound or is it outbound? In this case, it's going to be traffic coming into the interface. Alright, it's now applied. Actually, I was joking about breaking OSPF. I don't want to do that. That would be bad. Okay, so you see here on serial 10, there's my access group command. Alright. Now, if I go back to R1, and I ping 2.2.2.2, hey, it works. Alright. My source address when I do a ping, okay, from a router is the IP address of the interface that those packets are exiting. That's the source address. Now, I can manipulate that with the ping command. I can do what we call an extended ping. So I can tell it, you know what, I want you to form the packet so that the source address is this IP instead of this IP. This is how you do that. You type in ping and you hit enter instead of putting an address afterwards. It's going to ask you, well, what protocol you want to use? I want to use IP. What's the target address? Well, the target address is going to be 192. Actually, we did 2.2.2.2. Okay. How many times do you want to ping it? 5. What's this datagram size? Make it 100 bytes. Timeout between each packet if failure 2. Do you want to use extended commands? Yes, I do. What's the source address? So this time I'm going to make it the IP address of the fast Ethernet port, which is 10.0.0.1. Everybody remember that? Right here. 10.0.0.1. Okay. Service is 0. Everything else is default. Just kind of hit enter all the way through. U stands for unreachable. that access list blocked it. That access list blocked it. Okay? Now, I go to R2, and I simply remove it, no IP access group 10 in. Go back and do the same thing. It works. Okay? So that's how a standard access list is written and applied to an interface. All right? Now, let's take this one step further. This is very important for Lab 1. This is how you can control access, like telnet access to a router. So first off, I needed to set up a user and set up telnet access to R2. How I do that is, if I can create a user, let's just say I'm going to create a user B Brown with password Cisco. Okay. I'm going to set an enable password of Cisco as well. Access is controlled by some sort of port, either a physical port or a logical port. If you had a physical router, it would have two ports on it. It would have its auxiliary port and its console port. And you can cable up to the console port, use a program like TerraTerm or PuTTY, and physically connect to it. All right? But I'm simulating a network, so I'm simulating that I'm getting these routers via some other protocol. So if I were to be on R1, say I'm where R1 is located, and just for argument's sake, let's say R1 is Los Angeles and R2 is New York. I couldn't physically walk over to R2 and connect to it and configure it, right? I'd have to actually use some other means. All right? Typically what's done is maybe Telnet or SSH. So in this case, I'm just going to use Telnet as an example. So I need to go into my virtual terminal lines. So just like going into an interface mode or router configuration mode, you also have a line configuration mode. Okay? Your line can be your console, can be your aux port, or it can be your virtual terminal lines. All right? If I do a show run and look at the configuration, those configurations are at the very end of the config file. Line con, line aux, line bty. As you can see, I have login here already. I need to change that on the bty line. So I'm going to go into line configuration mode, line bty 04, just like it's in the config. Change that to login local. Write that to memory real quick. Now if I go to R1 and I type in telnet and tell it to go to 192.168.0.1, I'm prompted for a username. Give it B Brown. It's asking for my password. I give it my password, which you can't see. Hey, I got into R2. If I type in enable, I put in an enable password. Again, that's not going to be shown when I type it. Now I'm in R2. Pretty cool, huh? Now let's develop an extended access list that will block that, but permit all other traffic to go through. Here's how we do that. Let me get out of R2 first real quick. So let me just do a little bit of cleanup here real fast. I'm going to remove access list 10. How I remove a command is I preempt it with no. Check my work. And I can see access list 10 is gone completely. Now I'm going to write an access list. 101. Okay. Permit. Actually, excuse me, deny. So I want to deny the traffic. Alright. Now, typically I could put in a specific IP address, specific IP network, but let's just say that I want to deny telnet traffic wholesale from anybody. There's a keyword that I can use here, okay, after I tell it what protocol, which would be any. Okay, and remember, an extended access list works on source and destination. So, telnet uses what protocol for transport? Everybody know? TCP, good job, TCP. Alright. Any source, any destination with port number. What's telnet's port number? EQ stands for equals. What's telnet's port number? 23. Okay. A little bit of help. This website, you just do a iana.org, or excuse me, a Google search for TCP port numbers. This is the first link that pops up. This is older than dirt. This has been on the internet since, geez, I was like a teenager. It tells you every port number and what it is. So if we go to port 23, that's Telnet. Tells you who developed it, or who, excuse me, not developed it, but who registered it. And it will tell you the RFC that it works under. Okay? So when you see items in your labs, in your test of allow traffic for this protocol, deny traffic for that protocol, and you're unsure of the number, the access list, you can go to this website and figure it out. You can also, because Cisco got smart and they wanted to help you, why I don't know, but they did. You can also do the EQ space question mark, and it will give you the most common protocols and port numbers. As you can see, Telnet's there. So I can just type in Telnet or just give it port 23. Now, since I denied Telnet, what do I have at the end of any access list? No, not that's access group, not access list. An implicit deny. So if I don't put a permit here, I'm not only going to block Telnet, I'm going to block everything else. Very common rookie mistake. Okay, hey, I wrote my access list, I'm good to go. And it was a deny. Right? And you didn't permit stuff going back through. You denied everything. Yeah, worked really well. A little too well. So we need to put a permit in here. Okay? So I'm explicitly going to deny one certain protocol in this case. And I have to let everything else through. Okay? Not really a good practice. I'm using this more for an example than anything else. You should never have this in any access list whatsoever. Okay, so I just want to make that caveat there before I move forward. If I find permit IP any in any of your access lists, that's a bad thing. You're going to definitely lose points. Okay? So all of you guys who are recording this, make sure you pick that point up. So now if I go